Okay, so here we have another chain rule situation. To get the derivative of this guy, we've got the outside function, which is natural log, and then we've got the inside function, which is all of this stuff right here. So the derivative of the outside is 1 over, leave the inside alone, so inverse sine of x to the fourth minus 3 to the x is going to be left alone, and then times, then you have another chain rule. So now here, now that we're inside of here, now we have another outside function, which is the inverse sine. So the derivative of this outside is 1 over the square root of 1 minus, and then it's normally x squared, but since we have a different inside, we have to leave that alone. So x to the fourth minus 3 to the x squared times the derivative of that guy, which would be 4x to the third minus 3 to the x times natural log of 3. And that's it. Okay, so this question is, it's giving you a function, x plus cosine of x, and then it wants you to evaluate the derivative of the inverse at 1. Well, you can't actually find the inverse of this function explicitly. And remember, you had that formula that the derivative of f inverse is equal to 1 over f prime at f inverse of x. Okay, so remember, we need to find two things. We need to find f prime of x, and we also are going to have to find, since we're going to evaluate it at 1, we need to find f inverse at 1. So those are the two things that we need to find before we can use the formula. So f prime of x is going to be 1 minus sine of x. And f inverse of 1, so remember what this means is that this is saying when this whole function is equal to 1, what is the x value that gives you that that y value of 1. And usually, you know, this is a simple thing to find. So notice that if you plug in 0, cosine of 0 is 1, and then plus 0 is equal to the number 1. Okay, so I've got these two guys. So then I've got that the derivative of f inverse of x evaluated at 1 is equal to 1 over f prime. Let me do it in two steps. So f prime of f inverse at 1, which is equal to 0. So this guy right here represents f inverse at 1. Okay, so then this guy right here, this is going to be f prime at 0, which is going to be 1 minus sine of 0, which is simply 1. So then the result is just equal to 1. Okay, so I want to find the derivative of the inverse of this function at x equals to 1/3. And so the formula for this guy, remember, is 1 over f prime at f inverse at x, which in this case is 1/3. Okay, so I need to find two things. f prime of x and f inverse at 1/3. So f prime of x, to get the derivative of this guy, the easiest way is to rewrite this as x plus 1 to the -1. You can also use the quotient rule, but this is a little bit easier. So I'm going to do the chain rule here, which is going to give me minus x plus 1 to the -2, which is -1 over x plus 1 squared. Okay, so that's the derivative of the original function. And then f inverse of 1/3, that just means when this function right here is equal to 1/3, what's the x value? Well, that's pretty easy to see, that it's equal to 2. So then this guy is equal to 1 over f prime at f inverse of 1/3, which is 2. So this is going to be 1 over f prime at 2. Let me do that over here. F prime at 2 is equal to -1 over 2 plus 1 to the 3rd. So this is -1/9. So this, when all is said and done, this is equal to -9. Alright, so we've got some insane madness here. We want to find the derivative of this whole thing. And so we're going to crack at it one step at a time. So looking at the most outside function, I've got this guy right here, cosh, inverse cosh. And its derivative is 1 over the square root of x squared minus 1. But instead of x squared, I'm going to have all of this inside stuff squared. So natural log, sinh, square root, 4 to the 2x to the 4th minus inverse tangent of x. And this was meant to go all the way through. Okay. Alright, so this guy squared minus 1. Okay, and then times the derivative of the inside. So here, my first inside is the natural log function, which is, its derivative is 1 over the inside. So the inside is going to stay the same. Sinh of the square root, let me make this bigger, 4 to the 2x to the 4th minus inverse tangent of x times the derivative of its inside, which is this guy right here, sinh. So let me get a little bit more room. So now I have the derivative of sinh, which is positive cosh of leaving the inside alone. So 4 to the 2x to the 4th minus inverse tangent times, again, now the derivative of its inside, which is all of this. So the derivative of that is 1 over 2 square root of the inside, leaving it alone, 4 to the 2x to the 4th minus inverse tangent. See, it's like a little shell that you just keep cracking at. And then times, now I've run out of room, so I'm just going to put the derivative of this inside, I'm just going to put it right on top. So here the derivative of this guy is 4 to the 2x to the 4th, because the derivative of this guy is itself, times natural log of 4 times the derivative of its inside, which is 8x to the third, minus the derivative of inverse tangent, which is 1 over 1 plus x squared. And that right there is the derivative of that monster. That whole thing right there. Now, where are you going to use this in real life? Well, never. But it's still, you know, still fun. Fun times with the chain rule and all the other rules.